Okay, a little more on synthesis. Again, I really highly recommend that you read A Good Synthetic Strategy. There was a reason I wrote that, and when I wrote it, the students said it really helped them to do synthesis. Please read it. Just read through it. Give it a try. Okay, basically what it tells you in there is how to reverse positions in a molecule. And that's what I did a couple weeks ago in our problem session. So, first of all, to activate an alkane, if you just have an alkane like this, you have to do a free radical bromination. I use bromination because bromine is more selective, so that enables you to put a bromine in if you need to. The byproduct is HCl, HBr rather. You should review that reaction. To reverse positions, so for example, say I've got the bromine in there, the way that you reverse functional group positions is by elimination and then re-adding. So if you had something like this, and let's say you added a bulky base to it, all right, elimination means you have to pull off a beta hydrogen, you would end up with this, okay? If you get the double bond in, a double bond is a great place to switch positions. So to switch positions, for example, I could add HBr and peroxides and a little heat. If I do that, the bromine will be in the other position. And then I'm in a position to substitute things or do whatever I want to that bromine. Okay? So activation, bromine. You do have to do elimination sometimes if you want to move the functional group from the 1 to 2 position. Another way you could reverse the position is adding an OH. Okay? Now, another tip is very frequently you have to remove hydrogens. And you have to face the fact that if you really want to do some chemistry, you're usually better off doing it with strong bases, strong nucleophiles. You're allowed to rip protons off, and a lot of people are afraid to do this. So for example, if I wanted to make this molecule, okay, and let's say my starting material was this and bromomethane, okay, and I'm sorry to be a little repetitive, but there's only so many syntheses you can do. But if I had something like this, what I would consider doing is trying to do some kind of substitution on this methyl bromide. It could also be done the reverse way. The reason I know it's a substitution is I'm going from something that's sp3, completely sp3 hybridized, to something else that's completely sp3 hybridized. That means I have to substitute something for that bromine and keep that methyl intact. It has to be a substitution. To get a substitution going, though, I have to have a nucleophile. And a double bond is not a nucleophile. So how do I create the nucleophile from this double bond? At least it's not a traditional nucleophile. What I would do is I would want to put an oxygen in on that end position. How do I do that? You do it with hydroboration. So this is one of the 4 or 5 reactions that I said you really have to know. And I follow that up with some hydrogen peroxide and some base. Okay, then I would obtain this. If I have this and add these two together, if I add this butanol to this bromobutane, they are not going to react. And the reason they're not going to react is this is not a strong nucleophile. How do you create a strong nucleophile? You have to rip the hydrogen off. So today somebody asked me how to do that, and I said, well, you got to use something pretty strong. So what you could use would be maybe sodium hydride, sodium methoxide, or sodium alkoxide of some kind, or you could use super base, but I think super base is a little bit too super. This hydride will pull that H off, and it'll form this alkoxide. And if you get the alkoxide with this alkyl bromide, you can do a direct substitution to form that product. Okay, so lastly, let me just do another problem. Okay, supposing I wanted to make something like this. And again, you are somewhat limited as to what you're capable of doing. Supposing I wanted to make, like, let's say that. Okay, that's kind of complicated. And let's say the starting materials are this, and that's it. Those are pretty simple starting materials. Now, as I said before, and what I'm saying is I'm going to build this whole molecule just from these two little pieces. What I said before is that you have to think about the carbon-carbon bond forming reactions that you need to do. So if I were looking at this, I would say this molecule has 6 carbons, 7 carbons, 8 carbons. So somehow I've got to build an 8-carbon skeleton out of these pieces. Now remember, you can use any of the pieces more than once. If I were looking at this, I would think about the fact that I'd need 2 of these pieces and 1 of this piece. Okay? So what carbon-carbon bond reactions would be suitable? To make this part of it, what would be suitable is a Diels-Alder, because it's a 6-membered ring. To put this extension on, what would be suitable is some kind of an epoxide opening. And again, so to make this connection, I would need some kind of epoxide opening. Why am I thinking this way? Because you really only have a couple CC bond formations. So my synthesis would really involve taking this and reacting it with this as a very fundamental component. In doing so, I would be able to make the 6-membered ring. And the great thing about the 6-membered ring is the 6-membered ring has a double bond in it, and somehow with that double bond, I'm going to create that little extension that I need. So let me show you the whole synthesis. I'm not going to do this synthesis backwards because I think it might be too overwhelming. So first of all, how do I get the 2 Diels-Alder components? I actually need two equivalents of this, as you'll see. How do I make this? I'm starting with alkanes. If I'm starting with alkanes, as I indicated earlier in the earlier video, I would first have to activate the alkane. How do you activate the alkane? You brominate it with light. This is kind of like your starting reaction if you want to get functional groups. So I get that. Okay? When I obtain those reagents, I can start doing eliminations, or I could brominate it again. But I could take this and eliminate it using a bulky base, and I would obtain this. And if you wanted to further brominate it, you could. So I could brominate it again and follow that up with bulky base again. You get the idea. So you're going to see the way we make double bonds is always the same deal. Clem, how much time do I have?
You're at 8:40 now.
Oh, I better wrap it up. So I can make that. I would eliminate this the same way. T-butoxide, DMSO. Double bond. Okay? Now, once I get those pieces, you'd want to do a Diels-Alder reaction. So again, I'm centering the whole thing on the idea that I'm going to do a Diels-Alder and an epoxide opening. Okay. Diels-Alder. This is a very, like, the most basic Diels-Alder you could do. It's probably not the best Diels-Alder. There's my 6-membered ring. I made it. Okay, what do I have to do? I have to somehow get this hooked onto another 2-carbon piece with an oxygen on it. How am I going to do that? The only other thing you have available to you is the epoxide opening. So I have to make an epoxide, and I have to somehow activate that. All right, to get the ring ready, what I'd have to do is add HBr to the ring. By adding HBr to the ring, I'll get an H on one side, a bromine on the other side. Okay, so I made that bromide. If I make that bromide, as I showed you earlier, and you should put this in your bag of tricks, I could make a Grignard or an organolithium. So I'm going to make an organolithium. That would be this reagent. My byproduct on that step is lithium bromide. That's new, okay, but that's how you make the organolithiums. Now, if I could get this species to attack this epoxide, I'd pretty much be in business. So if this attacked here, this would open, and I hope you're seeing some repeating themes here, I hope. Okay, I would get that. If I take this and add some acid to it, I would have this primary alcohol. Can you see that, Clem?
Yeah.
Okay, I would have that primary alcohol. All right, now, how do I get this epoxide? So again, Grignard, Diels-Alder, bromine, convert it into an organolithium, we're reversing the polarity there, then attack the epoxide. The question is, where does the epoxide come from? Well, epoxides can be made from alkenes. How do you make an epoxide from an alkene? You should know that reaction by now. What reaction is that? It's the reaction with, again, MCPBA, or there was another method that I described in the earlier video. But if you used MCPBA and benzene, you would make this epoxide, okay, from the same alkene that we made before. Okay, now, the question is, how do you take this and convert it into this? Okay, that's an oxidation. That's what we started the semester with. How do you oxidize it? Well, you can't add chromic acid, because if you do, you'll get the carboxylic acid. So to stop it at the aldehyde, you would have to use Collins reagent. And I don't know if you remember this, CrO3